Welcome back. In this video, we're going to be talking about what hexadecimal is and how we convert numbers to and from hexadecimal representation. Let's begin by looking at the number systems which we know already. Since a young age, you've been using denary or decimal. You've recently learnt how to use binary, and if you haven't done so already, I'd recommend that you go back and look at the relevant binary videos. And now we're going to be looking at hexadecimal. Denary is also known as base 10, and it gets this name because it uses 10 different characters, 0 through to 9. Humans use this as it is easy for them. When you learn to count, you probably learned how to count using 10 fingers. Binary is a language used by computers, which is also known as base 2 because it uses 2 characters which are 0 and 1, representing electrical signals off and on. Hexadecimal is also known as base 16. It uses all of the characters which denary uses and the letters A through to F. The first thing that you need to remember in hexadecimal representation is that whenever you want to write a number between 10 and 15 inclusive, we have to write a letter instead. So if ever you want to write 10 in hexadecimal, you would write this as the letter A, all the way through to 15, which is represented using the letter F. To begin converting a number from denary into hexadecimal, we begin by writing the number in binary. To make 156, we add together 128 with 16 to get 144. We add 8 to make 152 and 4 to make 156. Once you've got your 8-bit binary number, we split this into nibbles, which are blocks of 4. We start with the least significant bit, which is 1, and make a group of 4, and we repeat this for the rest of the number. Now that we've got our number wrote in binary and split into nibbles, we convert each nibble into a hexadecimal number. Above each nibble, we write the numbers 8, 4, 2 and 1. Let's start with the left nibble. We can see that we've got one lot of 8 and one lot of 1. When we add those together, we get 9. In the left nibble, we've got one lot of 8 and one lot of 4. When we add those together, we get 12. As I've already explained, we can't write 12 in hexadecimal. We write it as a letter. So recall that 10 is A, 11 would be B, meaning that 12 is wrote as C. To get our final answer, we simply put the two together. We don't add them, we put them together to get 9C. Have a go at converting 63 on a piece of paper. Pause the video and I'll feed back to you shortly. We begin by writing 63 as a binary number. We don't have 128 or 64. 32 and 16 make 48. Plus the 8 is 56, plus 4 is 60, plus 2 gives us 62, and plus 1 gives us 63. We then convert the number into nibbles, so we split it into those groups of 4 first, and change our column headings to 8, 4, 2, and 1. If we start with the left-hand nibble, we've got 2 and 1. So that will be 3. In the right hand nibble, we've got 8 plus 4 plus 2 plus 1, which gives us 15. We can't write a number which is 10 or above. We write 15 as F. To get our final number, we just put the 2 together. So you should have a final answer of 3F. Well done if you got that. The next thing that we need to learn is how to convert a number from hexadecimal into denary. The first thing we're going to do with 59, I'm not saying it as 59 because I've not got 5 lots of 10 and 9 lots of units. I've actually got 5 lots of 16 and 9 lots of units. So the number at the top we're referring to as 59. Begin by splitting up each of the digits. And write them as a nibble using the values 8, 4, 2 and 1. Five would be made by adding together 4 and 1. 9 would be made by adding together 8 and 1. So you've got 2 nibbles, the left and the right. The next thing I'm going to do is just write those nibbles into my table. So I've got 0, 1, 0, 1 for the first one, and for the second, 1, 0, 0, 1. Now what we've got is a binary number, and I can add together 64, 16, 8, and finally the 1. When I add those numbers together, we get a value of 64 and 16, which is 80, plus the 8 is 88, plus the 1 is 89. So 59 in hexadecimal is equal to 89 in denary. Have a go at converting D8 from hexadecimal into denary. To begin with, we're going to split it up into components, D and 8. D is the equivalent of 13. So I'm going to write 13 as a nibble and 8. So 13 is made by adding 8, 4 and 1. And 8, we just write a 1 in the 8's column. Now that we've got those 2 nibbles, I'm going to write the left one in first, and then the right one. And I'm going to add the numbers together to get my answer. So 128 plus 64 is 192, plus the 16 is 208, plus 8 is 216. So the final answer for this one is 216. So in this video I've gone through what hexadecimal is and how we convert between denary and hexadecimal and vice versa. Please remember that when computers use hexadecimal numbers, they do not save hexadecimal numbers. They can only retain the values 0 and 1. A computer does not understand what a letter, or indeed any number which is 2 or above, actually is, as it cannot save it. Thanks for watching.